Hi, everyone. Today, I will introduce our accepted paper, which is a conditional probability framework for compositional zero-shot learning. So, first of all, what is compositional zero-shot learning? Compositional zero-shot learning is a subfield of traditional zero-shot learning, which aims to recognize unseen combinations of known objects and attributes by leveraging knowledge from previously seen compositions. That means the model only learn or see a subset of attribute-object compositions during model training, but notably, the subset contains all attributes and objects, but only some compositions. Okay, so what the traditional works do. As shown in Figure A, traditional approaches primarily focus on disentangling attributes and objects, treating them as independent entities during learning. However, this assumption overlooks the semantic constraints and contextual dependencies inside a composition. For example, certain attributes naturally pair with specific objects. For instance, striped applies to zebra or shirts, but not sky or water. While the same attribute can manifest differently depending on context, such as young in young tree versus young dog. Thus, capturing attribute-object interdependence remains a fundamental yet long-ignored challenge in compositional zero-shot learning. Different from prior methods, in this paper, as shown in Figure B, we adopt a conditional probability framework to explicitly model attribute-object dependencies. We decompose the probability of a composition into two components, the likelihood of an object and the conditional likelihood of its attribute. Now, I will introduce the details of our method. Firstly, to enhance object feature learning, we incorporate textual descriptors to highlight semantically relevant image regions. Then, these enhanced object features then guide attribute learning through a cross-attention mechanism, ensuring better contextual alignment. By jointly optimizing object likelihood and conditional attribute likelihood, our method effectively captures compositional dependencies and generalizes well to unseen compositions. As you can see, extensive experiments on multiple CZSL benchmarks demonstrate the superiority of our approach. In addition, we also present some visualization results including success and failure cases for intuitive observation. Thanks for your interest in our work.